If you're looking for guidance on implementing MLOps practices with Amazon SageMaker, you're in the right place. I'm Shelby Eigenbrot, and I'm an AI/ML Specialist Solutions Architect at AWS. And today, I'm honored to be joined by the Head of Architecture for Data, Analytics, and Machine Learning from Vanguard, Ritesh Shah. I'm sure everyone is excited to hear more about Vanguard's MLOps journey later in this session, but let's quickly take a look at what we're going to cover in this session. In this session, we're going to briefly talk about the scope of the session. Then we'll talk about some of the MLOps-ready capabilities built into SageMaker services and features. In this section, given it is a 300-level session, we'll also dive a bit deeper into SageMaker projects and SageMaker pipelines. I'll then turn it over to Ritesh, where he'll cover Vanguard's MLOps journey. And then finally, we'll do a brief wrap-up. As you can see, we have a lot to cover, so let's go ahead and get started. First, we'll set the stage quickly on the scope of this session. We won't spend much time here given it is a 300-level session. To begin, we understand that MLOps is the discipline that really sits at the intersection between the domains of machine learning, data engineering, and DevOps. Then MLOps as a discipline is enabled by a core set of practices that span people, process, and technology, where the intersection of those practices coming together really drives value in how we build, deliver, and manage machine learning models. That being said, MLOps is a broad topic, so if we look at all of these, and it's really better suited to a higher level session. So given this is a 300-level session, for today our focus is really going to be on technology, and more specifically, how to implement MLOps practices for SageMaker workloads, knowing that there really is no golden pipeline in the sense that there is no clear right or wrong answer to how you implement things like your machine learning pipelines. However, there are core practices that remain the same regardless of your technical implementation. As an example, your machine learning pipelines can look different depending on existing skill sets, looking at what has been standardized across your organization in terms of the tools that you need to use, or integrations with existing services or tooling that may be needed. Your pipeline can even look different depending on how you use SageMaker. So as an example, if you're bringing your own container, for training, you probably have a step inside your pipeline that builds that container image. As a result, even though the core steps and practices stay the same, the technical implementation can vary. So here's a quick look at some of the potential AWS services and third-party tools that can be used to create automated workflows and CI/CD pipelines for SageMaker. At the top, we have SageMaker native options of SageMaker projects, pipelines, and model registry that we're going to dive deeper into a bit later. At the bottom box here, we have a number of AWS services as well as third-party tools that can also be used. Again, the choice between what technical implementation to use can really depend on a few items that we don't necessarily have time to dive into today, but in general, the recommendation is to use SageMaker native services that are purpose-built for machine learning, and they provide those native integrations into SageMaker features and capabilities. However, it is still an option to also mix and match between SageMaker native features and do-it-yourself approaches. But for this session, we're really going to stay largely focused on the SageMaker native capabilities and features that really enable those MLOps practices. So this brings us to our next section, where we'll now start to dive a bit deeper into the technical challenges with building, training, deploying, and managing models, as well as those MLOps practices and SageMaker MLOps-ready capabilities that really align with and address those challenges. First, a common challenge is how to enable data scientists with the resources they need. So model building environments that give access to the compute and storage resources that data scientists need for machine learning, while still balancing the needs of IT, so ensuring things like security, reliability, and compliance. For this, the MLOps practice that aligns here is really everything as code, where in this case, you're creating those data science environments for model building activities using code. So let's take a look at how that looks. Here we recommend utilizing AWS Service Catalog to provide a consistent and repeatable mechanism to provision and configure data science environments that have guardrails implemented through code. So with Service Catalog, you create the templates that can be offered as part of a portfolio of products that are available to data science teams. So as an example, you may have a product for a basic data science environment that includes a new user in SageMaker Studio, an IAM role with scope privileges, and an S3 bucket. That product can then be provisioned using your pre-provisioned templates, typically written using CloudFormation, and that includes all of those pre-approved configuration options and guardrails that you want to enforce in those environments. The benefit with this approach is that you can ensure those environments can be repeatedly and consistently deployed for each new data scientist or data science project, depending on how your accounts and workloads are set up. This also allows you to identify a set of standards that really should be in place and enforce those standards through code. As an example, here we may be ensuring that an S3 bucket has bucket level encryption enabled for your data at rest. So balancing the needs of IT and data scientists during model build activities is one challenge, but there are several others that relate to more of the end-to-end machine learning development lifecycle that we'll cover next. So we're going to cover a few common challenges at once here, and then we'll look at the SageMaker built-in capabilities and features that help address some of those challenges. So the next challenge that we often see is bridging that gap between model build and model deployment activities. And this is typically because of the number of personas that are often involved in the end-to-end machine learning workflow and the handoffs between those steps that often occur. Without a consistent and repeatable process to track lineage of models and package models for deployment to higher level environments, it's really difficult to ensure the handoff between model build and model deploy activities will, one, not become a bottleneck, and two, not become an operational nightmare down the road because there isn't visibility into how those models are built, how those models are deployed, as well as a reliable way to track lineage and configuration in the event of failure or the need to debug. So here you'll see how SageMaker Model Registry can be used to address this challenge. The next challenge is really providing end-to-end traceability so that you have auditability within your pipelines. So for this, the MLOps practice that aligns here is continuous integration and continuous delivery, which isn't necessarily a new practice for software development, but it is relatively newer for machine learning. But with MLOps, we are also ensuring that we're including additional considerations that are very unique to machine learning, like versioning of data, as well as model versioning and lineage tracking. Here you'll see how SageMaker projects can be used to address this challenge. The next challenge is building a repeatable and consistent process for deploying models to improve your time to market, and also ensure that you're delivering high quality models to production that not only perform well for the ML problem that you're trying to solve, but also ensuring that you have a consistent and repeatable mechanism, again, to deploy those models in a way that's reliable and operationally efficient. Here you'll see how SageMaker projects and pipelines can be used to address this challenge. And finally, once a model is deployed, you need to ensure that you have identified a strategy to ensure ongoing performance of that model in production, because models can degrade over time. The data that you use to train your model may look different than the current ground truth data. And this is a concept known as data drift. Or you may end up with concept drift. So in either case, you need to ensure you have a system and strategy in place, such as SageMaker Model Monitor, that can monitor that model. So let's look at the range of features that SageMaker offers that are MLOps ready, meaning they help enable these MLOps practices and address some of the challenges that we talked about. First, let's use a typical machine learning workflow to go through the MLOps ready features of SageMaker, starting with data preparation tasks, which include things like cleaning your data, transforming your data, and feature engineering. SageMaker offers capabilities here that can be plugged into any machine learning workflow. So you can choose to use Data Wrangler to build your data transformation pipeline using a graphical interface, or you can use SageMaker Processing to build your data processing jobs. Either way, the tasks performed by these jobs can be easily plugged into your machine learning pipeline. You can also use Feature Store to store curated features that can then be used as part of the pipeline for your training activities. You can also see here that the general input to this step is raw data, or it could even be data that's had some degree of cleansing. And then there's two different outputs that you see here in this step that need to be versioned, which include your data processing code and your prepared data sets for training, validation of your model. Knowing these key inputs and outputs is key for traceability and lineage in building your pipeline. Next, you have your model building activities where you're typically running through a number of experiments to train, evaluate, and tune your model until it's performing as expected. Here, you want to be able to track each of those experiments using SageMaker experiments so that you can easily revert to the experiment that resulted in the best performing model, and you know the inputs that went into actually creating that model version. Then when you do find that model that is performing as expected, you can then register that model into the model registry, which stores key metadata about how that model was built, how it performed, and where it's deployed. You can also see here that we're picking up more outputs as we go as part of this step, including our training code and our model artifacts. Again, each of these needs to be versioned for traceability. Next, once we find that version of the model that's performing based on that minimum threshold that we've identified as a KPI, you can then use SageMaker deployments to take that model artifact, package it, and deploy it to one or more target environments. Similar to DevOps, where we build once, deploy many, with machine learning, we do something similar where we train once and deploy many without retraining between target environments. So in this deployment step, you're packaging your model, and then you choose the type of deployment option that meets your use case, whether that's to hosting services, using a persistent endpoint, or using batch transform or async inference. You'll notice here that we also use SageMaker Model Monitor to monitor the ongoing performance of your model over time so that we can be alerted when there's something like concept drift or data drift. All of these features of SageMaker can be used together, or you can pick and choose the features of SageMaker that make sense for your requirements and your use case when you're building out your machine learning pipelines. So we have all these workflow steps and tasks within each of these steps, but how do we actually build a pipeline that's able to automate these steps as well as incorporate all these inputs, outputs, and artifacts as part of a pipeline that has end-to-end traceability? So this is where SageMaker Pipeline comes in to tie all of these different steps together. Because SageMaker Pipelines is really the heart of what ties everything together, we're going to double click a bit more on this specific feature. SageMaker Pipelines was launched at re:Invent last year to help customers with the challenges of building machine learning pipelines by providing a Python SDK that allows you to build machine learning workflows. And that SDK has a lot of native integrations built in with SageMaker features that customers were really looking for, as well as the flexibility to extend your pipelines to non-SageMaker tasks. Second, a way to catalog models, meaning registering a model to a managed model registry that can be used to centralize model metadata about model versions. And SageMaker's model registry also includes the added capability of using that registered model version to trigger downstream deployment workflows. Then finally, there's built-in support for incorporating CI/CD practices such as source and version control for tracking lineage, as well as automatic pipeline triggers. So let's take a look at how all of this works by focusing on the three core components that are really making up SageMaker Pipelines. First, you have SageMaker Pipelines, which is that SDK that I talked about that allows you to build automated model build workflows that really focus on orchestrating the tasks and the steps that are required for your model building activities. And this typically includes the steps that are needed to prepare your data, train a model, evaluate a model, and then potentially register that model if it is meeting that minimum threshold for performance. This could be, an accuracy score or a specific threshold or whatever objective metric you're really trying to optimize your machine learning model for. Here, you typically iterate over a number of experiments until you find that model version that's actually performing well. So the key thing to note here is that these pipelines are often used during model development, but also the same pipeline code that's used during model development can be used during the operational phase for your model retraining activities. The second component of SageMaker Pipelines is Model Registry. So Model Registry is a managed registry that's used to centrally manage model metadata for model versions that come out of that model build phase that are performing well and they're candidates for deployment to other environments. So when I work with customers on building out machine learning pipelines, one of the first questions I usually ask is if they have a model registry in place, primarily because it becomes key for managing multiple versions of models for traceability as well as transparency. And a model registry can also serve as almost a contract and a handoff between the personas that are often involved and responsible for the tasks that happen between model build and model deployment activities. The final component is SageMaker projects. So SageMaker projects provide pre-configured MLOps templates, as well as the capability to bring your own templates. Each of these templates can be instantiated multiple times to automate the process of setting up and configuring your machine learning pipelines that also incorporate CI/CD practices, such as automated triggers and source and version control. So you can see that these templates cover the end-to-end workflow, or only the model build phase, or only the model deployment phase. And this is really to provide the flexibility for customers that may not use SageMaker end-to-end. As an example, if you're training outside of SageMaker, but you're using SageMaker or standardizing on SageMaker for deployments, you can choose a deploy-only MLOps project template. Another key thing to note is you can choose which components you want to use and which ones make sense for your requirements. So as an example, you can use pipelines without using projects. So we covered a lot here. Let's take a look at what all of this actually looks like with a quick demo. In this demo, I'll show you how you can use SageMaker pipelines, and more specifically, SageMaker MLOps project templates, to automatically provision and configure the resources needed to build a CI/CD pipeline for your model build and model deploy activities. To start, if you want to use SageMaker projects, you need to ensure that project templates are enabled for your Studio domain. This can be done when you're setting up your Studio domain, or it can be done by updating an existing domain in edit settings or programmatically, but it's simply a toggle that either enables or disables project templates. Now I'm going to show you what happens when we enable projects for our Studio domain. To do this, I'm going to launch the Studio app. Next, I'm going to go into SageMaker Resources here from the left-hand menu, and I'm going to select Projects from the drop-down. Now, because we enabled project templates for this domain, we can now click Create Project. And then you'll see we have a few options here. When we enabled projects in our domain, what we actually did is import a portfolio of products into AWS Service Catalog that includes a number of built-in project templates that are made available through this menu of options you see here in Studio. These templates are CloudFormation templates that allow you to consistently and repeatedly set up and configure your CI/CD machine learning pipelines through infrastructure and configuration as code. And as I mentioned before, and you can see here, there's a number of built-in templates that cover different scenarios, from end-to-end scenarios that encompass build, train, and deploy tasks as part of your pipeline, but also the option to select build and train pipelines or deploy-only pipelines. These templates support using AWS Code Commit for source control and Code Pipeline for orchestration, but there's also options to use third-party source control such as GitHub, GitHub Enterprise, or Bitbucket Cloud, or even the option to use Jenkins for your orchestration. So as you can see, there's a lot of flexibility in the built-in templates, but you can also choose to build your own templates as well. Now, these templates are made available under organization templates. One tip here when you're creating your own templates is you can always start with code from one of the built-in templates and then modify that to meet your requirements. Also, another thing to note is that often the personas that are creating these templates, so maybe an MLOps engineer or a DevOps engineer, may be different than the personas that are actually consuming these templates, like data scientists. So having said that, let's go ahead and walk through how to create a project using one of the built-in templates. For this, I'm going to select the model build, train, and deploy end-to-end template. So I'm going to select that project template. And this will bring up a screen that accepts input parameters for the chosen template. So in this case, it's only requiring the project name and optionally a description and tag. So for this, I'm just going to put a name in. And then I'm going to go ahead and click Create Project. Now, when I hit Create Project, this is actually provisioning and configuring a number of underlying resources like source code repositories, as well as the triggers and the integrations between the service underlying resources that are actually creating and building our CI/CD machine learning pipeline. So it's going to take a few minutes to provision, and I'm going to pause the video while it's provisioning. Now, once your project has been created, you'll see the resources that get created and associated with your project, depending on the MLOps project template that you've chosen. So in this case, we did the build, train, and deploy template. So you're going to see 2 code repositories. And these were automatically created in code commit and populated with seed code that allows you to see the recommended practices for working with SageMaker projects. And there are 2 repositories. There's a model build repository, which contains all of the data pre-processing, training, and evaluation code, as well as your SageMaker pipeline code that automates these model building tasks. The second repository that gets created contains the configuration and CloudFormation template code for your automated deployment pipeline. So you can see here that you can also clone these repositories to your local Studio environment and work directly with the code from Studio, committing changes as you iterate. After we've cloned, you can see over on the left-hand side, all of that code has been cloned into our local environment. And we'll come back to this in a moment. But next, you'll also notice under pipelines within our project, this is the pipeline components of SageMaker pipelines. But here you'll notice a pipeline that gets automatically created through that seed code in your model build repository. Now, if I click on this pipeline, you'll see an execution that's already in progress from that sample code. I'm going to go ahead and click on this execution. And you'll see here a graphical representation of your pipeline that's created through the provided Python SDK. And it contains your data pre-processing task, your training task, your model evaluation task, a conditional step in here to determine whether that model is meeting a minimum performance threshold, and if it is, a task to then register that model into the model registry as a final step. Now, to modify this sample code for your own use case, you can go into your locally cloned repository and modify it for your own use case. So for this, while this pipeline is executing, I'm going to go ahead and move over into our locally cloned repository and show some of the code. So here I'm going to click on pipelines. I'm going to click on Abalone. Now you can see within here that we have our model evaluation code. We have our data pre-processing code, but we also have our pipeline code. So if I click on the pipeline Python code, you'll see this is the code that is actually building out that pipeline that we saw that's executing right now. So using the Python SDK that's provided, you're able to basically take all of the model building tasks within your workflow and automate those into a pipeline that you can then execute on iteratively as you go through your model building activities. Now let's head back to the execution of our pipeline. Because these pipelines contain many tasks and steps, they can take a few minutes to execute through, but through the magic of a pause demo, our pipeline is now complete. A couple things I want to point out though is you can click on any step in your pipeline and get key information about that step, such as the inputs that were used, the outputs of that step. So here we see our performance metrics as well as the model artifact, as well as the logs or the results of that step. Another key item to point out is SageMaker Pipeline supports the use of runtime parameters. So these are parameters that you can specify at runtime for each execution of your pipeline. And what these allow you to do is provide configurable options for your pipeline without having to change that actual pipeline code. Another key feature to point out is SageMaker Pipelines automatically integrates with SageMaker Experiments. So if I go over to SageMaker Resources, click on Experiments and Trials, you'll see here, Pipelines automatically creates an experiment for each pipeline and an experiment trial for every execution of that pipeline. Now, the creation of the experiment and the experiment trial is done automatically, and it is turned on by default. And what this really allows you to do is, even though every model may not be a candidate for deployment, you're still going to want to automatically log and track key metadata around these experiments for experiment tracking. So things like metrics, the parameters, how it was built, the artifacts of that particular experiment. This is all automatically enabled through pipelines. So now if we go back to our pipeline, we see here again that last conditional step that's evaluating our MSV value met the threshold in this particular case that we identified in our pipeline code, so the model actually got registered to the model registry. So once you have that model that is performing according to the criteria that you've identified, that model version gets registered as a step in the pipeline. So if we go back to our projects, you'll see another resource listed here called Model Group. This represents your model registry. I'm going to click on this model group and you'll see version 1 from that most recent pipeline execution. And you'll notice that model version is in a pending status. By default, this pipeline registered the model version with an approval status of pending. This can be changed to automatic approval, but in this case, we're following more of a continuous delivery strategy where we have a manual approval step that's required before triggering our automated deployment pipeline. So if I go ahead and click on this particular model version, I can see key metadata about this model as well as performance metrics. So I can see what was used to actually build this particular model version, as well as the performance metrics that are tied to this model version. So assuming all of this data looks good, I can go ahead and update the status to approved. To do this, I'll click on Update Status, and I'm going to go ahead and change the status from pending to approved, and I'll just go ahead and note that it's approved for deployment. And then I'm going to click Update Status. When I update this status, what this does is trigger an automated deployment pipeline that's executed through AWS Code Pipeline as part of the resources that were automatically provisioned and configured with the MLOps project template that we use to create this project. Now, it takes a few minutes for that pipeline to run, but the built-in template will deploy a test endpoint. Then it's going to wait for manual approval inside AWS Code Pipeline before deploying a production endpoint. So I'm going to go ahead and pause the video for a moment while that pipeline runs. So once our model deployment pipeline has completed, you'll be able to see if you go back into your model registry, you'll see for version 1, this version is deployed to staging. You'll also be able to see this inside your SageMaker project if you go into the endpoints resources. And you'll see here that version is deployed into staging. So we have an in-service endpoint in our staging environment. Now, if we want to be able to take that same model version and deploy it to a production endpoint, assuming all of our tests have passed, what we can do is then go into AWS Code Pipeline, and this may be done by another resource that has approval to deploy to production. So maybe an MLOps or a DevOps resource, but we go into this pipeline that was automatically configured and provisioned as part of our MLOps project template. And you can see inside here, after the deployment to staging, there is a manual approval step for deployment to production. So I'm going to go ahead and review this and approve it for production deployment. And what this is going to do is trigger a deployment of a production endpoint. We can then go back over to our studio environment, and under the project, we'll see that we have a production endpoint that is in the status of creating. This will change to in service once that endpoint is up and available. So in this demo, I showed you how you can use SageMaker pipelines, and more specifically, MLOps project templates provided through SageMaker projects to automatically set up and provision the resources needed to create your end-to-end machine learning pipelines that incorporate CI/CD practices. So we just saw SageMaker pipelines, projects, and model registry in action, but we do want to highlight some of the features that have been added since launch that you may not be aware of. First, Pipelines natively integrates with SageMaker experiments like you saw in the demo, so there's no need to set up each experiment or trial. Pipelines will automatically track each experiment. Second, we continue to iterate on pipelines and include more natively supported steps such as automatic model tuning, AWS Lambda, and the addition of a custom callback step where you can include tasks run on other AWS services or even tasks run as external jobs inside your SageMaker pipeline. Third, we added support in SageMaker projects for third-party tools. So you can now use GitHub, GitHub Enterprise, or Bitbucket Cloud for your source control, as well as use Jenkins for your orchestration tool. This allows customers to use any existing tooling they already have standardized on as part of your pipeline. Next, we added automatic rollback, to a previous model version, which allows you to roll back a deployment of a newly deployed model version to the previous version if it's not performing well. Finally, we added several features into the model registry. One big one is the ability to have cross-account deployments and approvals. And this is important because we recommend multi-account strategies as part of your AWS setup for workload isolation, and the ability to deploy across accounts is key. So we just went through a lot of the challenges that we see with organizations, as well as some of the SageMaker MLOps ready features to address some of those challenges, in addition to diving deep into SageMaker pipelines and projects. But let's go ahead and switch gears now and hear specifically about how Vanguard tackled some of these challenges and hear more about Vanguard's MLOps journey. So now I'm going to go ahead and turn it over to Ritesh.
Thank you, Shelby, for showcasing all the capabilities that SageMaker platform has to offer from an MLOps perspective. And thank you for demo showcasing the capabilities in real life. Before we go deeper into Vanguard's MLOps journey, let's first spend a few minutes on Vanguard. Mission for Vanguard is to take stand for all investors, to treat them fairly, and give them best chance for investment success. Founded in May 1975, global asset under management around $8.3 trillion. We have 417 funds, 19 offices, 17,000 plus employees, and 30 plus million clients for whom we manage assets. Before Vanguard started their journey on building a machine learning platform, we started with setting up objectives that we want to meet. And the first objective that we set was reduce time to set up a usable platform by data scientists and data engineers. And the goal was to have that platform set up with all their needs in less than 24 hours. Second objective we set up for ourselves was reduce lead time to enable consumption of machine learning models by different applications and services. To achieve that, we built ourselves an objective of automating 100% of deployments of models. Third objective, while we build a very simple to use platform and reduce lead time to consumption, we wanted to make sure we reduce risk introduced due to machine learning. And to help with that, we want to automate validation of all the controls that a data scientist or a model has to adhere to reduce risk. Finally, fourth, we wanted to increase client satisfaction for usage of the platform. And we set ourselves a goal of 10% year over year improvement to the satisfaction from our clients. Now that you have seen the objectives we have set up, first thing we started is, hey, we want to set up a machine learning platform, but we want to first build out what we call a model development lifecycle, and then build capabilities around those lifecycle phases in related to MLOps. And while building this lifecycle, we came to a conclusion that model ops or MLOps and governance of models would have capabilities not as an isolated phase, but embedded in each phase of the lifecycle. So what is this lifecycle, right? And what capabilities do we offer? First one is, hey, define problem, right? Before you start building anything, you want to define the problem, document the problem statement, establish goals, understand what return on investment are you going to get by solving this problem, maybe identify potential risks that you would run into, And once all of those things are established, you would start setting up a team, a full stack team of a product owner, a owner for the model, data scientist, machine learning ops engineers, and many other personas that are required to build a model. Next phase is you would prepare data to understand your problem, and also you would prepare data iteratively to solve the problem. And there are several smaller phases built inside of that prepare data phase. Like, hey, you want to understand the data, you want to identify data, you have to identify gaps in data, you set up access to data so that you can use it for building your model, and post building the model, you can use it. And you build features that are conducive to your model by doing feature engineering. Apart from all that, you also want to spend some time on ensuring your data does not have any biases or imbalances. Once you have that data, you would start building the model. And it's not a once done, you set the data and then build the model. It's an iterative process where you go between prepare data phase and the develop phase. And at times you go back to define problem phase so that you can clearly understand the problem that you're trying to solve. And in develop model phase, what you typically would do is you explore different algorithms and frameworks, build and train different models via experiments that you want to conduct to prove your hypothesis of solving the problem. You would test, tune, optimize, and run trials. And then you would check if your trained model has any biases in the predictions that it is making. And then you follow other capabilities, like you would want to archive your code, you want to archive your model in a repository, you take your feature engineering code and archive it, etc. Post deploy or develop phase, what you would go do is, hey, you would go to a controls toolgate at Vanguard, establish how risky is your model. You have done that some analysis at the start of the life cycle, but now you have inferred more from trying to solve the problem. So you do a risk analysis and identify whether your model is low risk, medium risk, high risk, or extremely high risk. And those are different tiers of risk, which then drives towards what controls do you have to meet for you to be able to deploy that model for consumption. And you also make sure those controls are adhered to and practices followed, and seek an approval to deploy your model. And this approval step is very critical because you want it out of cycle. You want typically a data scientist to work with a panel or somebody else on the team to review everything that was done, and that person then approves the model that is being deployed. Next, you get into the last two phases, which is around deploying a model and monitoring a model, where you would validate the code and whether the code meets all your security standards at your organization. You would ensure all the controls are met, specifically from ITIL perspective. You would use CI/CD pipeline typically to deploy code rather than a human being deploying a code. And then as part of the pipeline, you would want to set up monitoring of your model so that at inference time, you can detect any anomaly or drift or biases coming out of the model. This complete life cycle gives you now an ability to think through all the different phases, including ops and governance, and what capabilities are to be built from a MLOps perspective. Now let's start diving a little bit deeper into how did we instrument the platform for different phases. And we are going to start with the define problem and prepare data phase. At Vanguard, as I said, we wanted to reduce time to set up platform and make it usable. So we came up with an automation where we leveraged chatbot technology, which the data scientists and teams interact with. And the first step they do is, hey, I have a new problem to solve, or I am a new team. I'm going to set up an IAM role using this chatbot directly into production. And this chatbot enables MLOps capabilities of setting SageMaker for experiment, setting SageMaker up for debugging and clarify, which is used for bias and explainability. It also goes and sets up model registry and also sets up other services that you may need, like Amazon Athena, to query your data and prepare your data. All of this is done through the chatbot interface. Next, the same team, because they are trying to solve a new problem, they would go to the chatbot and set up access to data. And chatbot automatically updates the IAM role with S3 buckets that you need access from the data lake. It also creates an experimentation bucket so that you can transform data and store it and use it in your model for training. And it also sets up access to Amazon RDS, Glue, and other data stores in future. Next comes the third step, is the team goes to the chatbot and sets up their project environment within SageMaker Studio. As part of that setup, the chatbot has automated setup of CI/CD pipeline. It goes and sets up code repositories of two types. One for actual notebook code where data scientist builds all this capabilities, but also sets up a configuration repository where machine learning engineers can provide configuration for endpoints or batch inferences that they want to conduct at a later stage of this life cycle. Last, it also sets up an S3 bucket, which is tamper-proof. Object locking is turned on so that you can deposit your trained model in a location and the data used for training in a location that is tamper-proof. This will help meet all your MLOps and governance requirements around code and data being tamper-proof. Last piece, the team uses the chatbot and associates their project with that team, which ultimately gives them the access to the project to begin their next phase. Going into the next phase, which is the third phase of developing the model, data scientists use SageMaker Studio notebooks. As Shelby explained, they use SageMaker pipelines capability, where they orchestrate different steps of processing data using SageMaker processing or EMR or Athena, or add SageMaker experiments and training steps so that they can run multiple experiments and trials, and also add a step to check for bias and model explainability using Clarify and SageMaker Debugger as steps of the pipeline. At the tail end of the pipeline, when all these trials are completed, they would also add a step in their notebook to register the model into SageMaker Model Registry. SageMaker Model Registry now at that point becomes that central place where you can go and inspect your model, look at what data was used for training, how many versions of trainings were run, etc., etc. All those model ops and governance capabilities are available in Model Registry. Data scientists continue on to use SageMaker Studio to take all their notebook code and configurations and push it to code commit as a code repository. Vanguard also allows data scientists to bring their own containers for algorithms that they want to bring in rather than just using AWS native containers. So we also have a code repository dedicated for data scientists to be able to check in their Docker images, which will be used during the deploy phase of the model. Now going on to the last three phases, which is around controls, deploy, monitor phases of the life cycle. And let's start with the controls phase. The owner of the model, like I said, would go to the chatbot, answer questions on different perspectives that were used to build the model. And these questions would help the model owner determine what is the risk tier of their model. And chatbot automatically takes that risk tier and tags it to the SageMaker project that was created, but also it applies that same risk tier tag to the model registry or the model in the model registry. And the whole risk questionnaire or questions that were answered are all archived in S3 for future analysis of what were the answers to those questions when the risk tier was determined. Once the risk tier is established, model owner goes to model registry, approves the model, and moment they approve the model, SageMaker CI/CD pipeline kicks in automatically and executes the CI/CD pipeline. As part of pipeline at Vanguard, we check for security vulnerabilities in the code that may have been introduced. We check quality of the code. In future, we are enabling a step to check if all controls were met or not. It would then deploy containers. If you built your own container and brought in your own container, it would go ahead and deploy it to ECR, and then it will create a production change record in ServiceNow, deploy the model, and then set up monitors for the model as full automation as part of CI/CD. Let's dive deep into the last phase, which is the monitor phase. Data scientists go to the SageMaker notebook, use the SageMaker UI or the SageMaker notebook interface to write code, and they would go and set up monitors for different capabilities that SageMaker has to offer. Capabilities that are offered at Vanguard are data drift for quality, model quality, bias drift, and feature drift. Now let's talk about some key takeaways, right? Building MLOps and governance platform as part of ML platform is a journey. It's not once done and complete. It's a journey that you'll have to continuously evolve and grow into. Like Shelby mentioned, SageMaker Studio and SageMaker overall has many capabilities available already for you all to use and embark on this journey. But I would say invest in enabling these capabilities, as it will help your data scientists and help you and your companies to be more effective at MLOps and governance of models. From a future perspective, Vanguard's looking at enabling CI/CD for not only AWS native containers and bring your own containers. That's the work that we have already started, and we are going to expand from there on to allow data scientists to bring in pre-trained models, which would also meet all the MLOps and governance requirements at Vanguard. Enable feature engineering capabilities in your ML platform because it's an important piece of your lifecycle for MLOps. And in future, Vanguard's expanding capabilities in the space to include feature store and build a custom CI/CD pipeline just for feature management. Enable model monitoring as part of your MLOps needs. And currently, you can do it for endpoints as part of SageMaker and its capabilities. In future, expand that capability not only for endpoints, but for batch, and expand those capabilities to cover operational health of your endpoints from a perspective of memory usage, CPU usage, GPU usage, so that you can tweak and tune your models that are deployed to be more effective. Last, enable CI/CD and automation to streamline consumption. That's a very important step from an MLOps perspective and helps streamline governance of models. We at Vanguard want to now go beyond CI/CD and expand into the realm of continuous training and continuous monitoring and add those capabilities to our ML platforms to complete the full cycle of MLOps. Finally, thank you for listening to me, and thank you, Shelby. Handing it over to you for next steps.
Thank you so much, Ritesh, for sharing your story on how you set up repeatable mechanisms to ensure that you're consistently able to meet the needs of your data scientists, as well as maintain the controls and governance that are often needed, especially in heavily regulated environments. We'll wrap up here with a few tips as you're looking to implement MLOps practices with SageMaker. First, start small and iterate. Often teams can get stuck in analysis paralysis by trying to build out platforms or pipelines that solve every possible scenario. Start with a few patterns and build from there. The second, practice everything as code to ensure repeatability, consistency, and governance through provisioning and configuring resources using code that is under source control and version control. Third, ML pipelines are different than traditional application feature function pipelines. So make sure you're considering the steps and the tasks that are specific to machine learning, like data processing and training, as well as making sure that you're considering the additional inputs and artifacts that need to be incorporated into your pipelines to provide that full visibility for lineage as well as end-to-end traceability of your pipeline. Fourth, use the integrated services that are native to SageMaker that I covered earlier. Those are really the easy button to be able to reduce the setup time that's required to build out these CI/CD machine learning pipelines. And then finally, implement a model registry as part of your ML pipeline, as well as to help bridge that gap that often occurs between model development and model deployment phases. As a final note, we recently launched a MLOps page, so I definitely encourage you all to go check it out to learn and have more resources on implementing MLOps practices with SageMaker. Thank you all so much for your time again, and a special thank you to Ritesh for sharing your story with us.